Assalamu alaikum class. I hope that you all are fine. Today I am going to discuss about hybridization. Last time we have studied about the compounds of carbon and different categories of compounds of carbon, and today we will discuss about their hybridization. What is hybridization? Now a brief introduction and its types. Hybridization is the mixing of atomic orbitals. We can say that atomic orbitals intermix to form new orbitals and new orbitals has same shape and same energy. If any orbital have same shape and same energy, then we can say that these are degenerate orbitals. These are degenerate orbitals. And we also call these degenerate orbitals as hybrid orbitals. Again, it is the mixing of atomic orbitals. Atomic orbitals of valence shell like S, P, D and F. These orbitals will intermix and form new hybrid orbitals, and these hybrid orbitals have same shape and same energy, and these are also known as degenerate orbitals. On the basis of involvements of these orbitals, hybridization is categorized into different classes. It has different types, like first is sp3 hybridization. Second is sp2 hybridization. Third is sp hybridization. Fourth may be D2sp hybridization, D2sp3 hybridization, DsP3 hybridization, and F may also involve in a hybridization process. Now a little discussion about sp3, sp2 and sp hybridization. We can define sp3 hybridization as 1s. S is atomic orbital, and 3p. Keep in mind that I have written the term 3 in words. We cannot write it as 3p. Why we cannot write it as 3p? Because it means that only third orbit of atom is taking part in hybridization. But in this case, it means that 3p, it means first, second and 3 p's will take part in hybridization. 3 p's atomic orbitals will mix to form sp3 hybrid orbitals. You people may compare this definition with the actual definition, that in this case atomic orbitals are going for intermixing, and in this case we are also looking that 1s and 3p atomic orbitals are intermixing with each other, and forming sp3 hybrid orbitals. In this case, what will be the ratio of s and p? What will be the ratio of s and p? S has 1 and p has 3, and we can find the percentage that s will be 25% in the orbital, hybrid orbital, and p will be 75% in the hybrid orbital. In case of sp3, 1s and 3p atomic orbitals will intermix to form new sp3 hybrid orbitals. These are sp3 hybrid orbitals, and in this case their ratio will be 1:3 and their percentage will be 25%. S will have 25% character and P will have 75% character. For example, CH4, methane. Methane is a basic hydrocarbon and it falls in the sp3 hybridization category. Ethane and stop. As you have noticed that I am just giving you example related to just organic compounds because we are dealing with organic compounds. In this category there are many other compounds that also fall in sp3 hybridization like water, ammonia and so many others. In case of sp2 hybridization, we can write its definition as 1s, 1s and there are 2 p's, so 1s and 2 p's, 2p atomic orbitals intermix to form new orbitals and those new orbitals are actually sp2 hybrid orbitals. New orbitals are sp2 hybrid orbitals in this case the ratio will be 1:2 and their percentage may be S will have 33% character in hybrid orbital and P will have 67% character in hybrid orbital. Here are some examples like CH2 double bond CH2, it's ethene, and we can write BF3 boron tetrafluoride, but I am not going to discuss about inorganic compounds. It's just related to organic compounds. It will be discussed in chemical bonding of first year chapter. In case of sp hybridization, we can define it as 1s and 1p atomic orbitals will intermix to form new sp hybrid orbitals, and their ratio will be 1:1, and their percentage character in a hybrid orbital will be 50%. 50% will be S and 50% will be P. And its example is ethyne. We have studied about hybridization and I am going to repeat it intermixing of atomic orbitals, to form new orbitals, and those orbitals have same shape and energy. And if orbitals have same shape and energy, those orbitals are known as degenerate orbitals. And we also call them hybrid orbitals. According to the atomic orbitals, hybridization may have different types, but we are now focusing on three basic types. First is sp3, second is sp2, and third is sp hybridization. In case of sp3 hybridization, the term sp3 is telling us about its definition, that in this case 1s and 3p atomic orbitals are taking part in mixing. They are mixing with each other and forming sp3 hybrid orbital. Then I have written about their ratios and percentages and again examples. In case of sp2 hybridization, 1s and 2p atomic orbitals will intermix to form sp2 hybrid orbitals, and in case of sp hybridization, 1s and 1p will intermix to form new hybrid orbital. Students, now moving towards some examples of hybridization. First of all, that's methane. First example is methane, CH4. First of all, write the electronic configuration of central atom in its ground level or ground state. Carbon has 6 electrons and its ground state is 1s2, 2s2, 2px1, 2p1 and 2pz0. After getting some energy, the electron of second s, 2s, it will jump toward 2pz atomic orbital. Then the excited state of carbon will be, it is the excited state of carbon and it will be 1s2, 2s1, 2px1, 2py1 and 2pz1. Now we have to think that how many orbitals will take part in mixing. Just focus on the compound, that in this case carbon is making part with 4 hydrogen atoms, so 4 atomic orbitals will intermix to form new hybrid orbital, and 4 orbitals will be these 4 orbitals. And in this case 1s and 3p's, 1s and 3p's are intermixing, so it is sp3 hybridization. It is sp3 hybridization. We can find the hybridization by following these steps. In this case, we came to know that 1s and 3p atomic orbitals are intermixing to form sp3 hybrid orbital, so it is sp3 hybridization. Now draw them in block form. It is 1s and these are hybrid orbitals, first, second, third and fourth. It has 1 electron, 1 electron, 1 electron and 1 electron. These are all sp3 hybrid orbitals. It is also sp3 hybrid, sp3 hybrid, sp3 hybrid and sp3 hybrid. We have seen that in this case one hybrid orbital will have 25% s character and 75% p character, or we can say that one orbital will have 1:3 sp. And another thing, if you are going to draw hybrid orbital, you just have to draw just single loop, as And if you are going to draw unhybrid orbital, then you will have to draw two loops, as it is for unhybrid and it is used for hybrid orbitals. Now moving to our next step, here other atoms that are making bond with the central atom will overlap with these hybrid orbitals, like in this case hydrogen, it's one electron, and another hydrogen having one electron, hydrogen having one electron, hydrogen having one electron. These hydrogen will overlap with these sp3 hybrid orbitals. As now, what will be the geometry of CH4 or methane? Just focus. First hybrid orbital is like as. Second hybrid orbital will be drawn. Third hybrid orbital, and fourth hybrid orbital I am trying to use different color. It's fourth hybrid orbital, and each hybrid orbital contains a single electron, just single electron as. And in this case, one hydrogen will overlap with this hybrid orbital. In this case, the geometry of the molecule will be tetrahedral. Geometry will be tetrahedral. And angle between this hydrogen, carbon and hydrogen will be 109. This angle will be 109. Sorry, 109 will be the angle between hydrogen, carbon and carbon, and its geometry will be tetrahedral. We can just find the hybridization state of any compound by following these steps. Now moving toward next type, next example of hybridization. Here is ethene. Ethene. Now look at the compound or molecule structure, that here is one carbon and another carbon. We can take just one carbon as a central, and other carbon will automatically be central atom. So I am going to take this carbon atom as a central point. So its electronic configuration at ground state, 1s2, 2s2, 2px1, 2py1 and 2pz0. Its excited state will be, I have told you that one electron will jump from 2s to 2pz, and it will be 1s2, 2s1, 2px1, 2py1 and 2pz1. Now in this case, again we have to check that how many atoms are attached with the central atom. I am going to write it at open as a structural formula. In this case, one carbon is attached with other carbon, and that carbon has two hydrogen atoms. Now we can see that in this case, one carbon is making bond with three atoms. One hydrogen, another hydrogen, and just single carbon. So the first three atomic orbitals will take part in mixing. So I am going to write them, this one and this px and this py. First three orbitals will take part in bonding, in mixing In this case, we are looking at 1s and 2p atomic orbitals are overlapping or mixing. So this will be sp2 hybridization. sp2 hybridization. How we came to know? That we have seen that inner orbitals 1s and 2p atomic orbitals are going to intermix and they are forming ethene molecule. Now block from 1s2 and here are hybrid orbitals and here is unhybrid orbital. Second carbon will also have same situation, 1s2 hybrid orbitals and here is unhybrid orbitals. Now writing their names, it is sp2 hybrid orbital, it is also sp2 hybrid orbital, sp2 hybrid orbital, and it will be spz unhybrid orbital. It will also be sp2 hybrid orbital, sp2, and it will be 2pz unhybrid orbital. Now looking their electrons, one electron, 1, 1, 1, 2, second, and in this case 1 electron. Now going to next step, that's overlapping with other atoms. First look at one carbon is making bond with another carbon atom. In this case, this carbon will make bond with another carbon atom. And it will be sigma bond. It will be sigma bond. And this sp2 hybrid orbital will make bond with the hydrogen atom for this carbon. And in this case, another hydrogen will be overlapped with another hybrid orbital. In this case, the second carbon will also make bond with two hydrogen atoms. Here will be one hydrogen atom and second hydrogen atom. Now you have attached all atoms that are present in a compound, but look at there is a double bond. In this case, one bond is sigma and second is pi bond. And here is the formation of sigma bond. Now we are missing just pi bond, and that pi bond will be formed by 2pz unhybrid orbital. They will overlap side by side and will make pi bond. Now forming its structure. How we can form its structure? Just for one carbon, has 3 hybrid orbitals and 1 unhybrid orbital. First of all, draw hybrid orbitals. Here is one hybrid orbital, second hybrid orbital, and third hybrid orbital. Now draw unhybrid orbital, and I am using different color to differentiate that it's unhybrid orbital. Here, it's unhybrid orbital having double loop. And second carbon also has similar type of hybridization. One hybrid orbital, second hybrid orbital, and third hybrid orbital. And fourth unhybrid orbital, double loop unhybrid orbital. Now putting electrons in these orbitals. All orbitals has just one electron, so it has one electron, and one electron. In this case, one electron of this hybrid orbital and one electron of this hybrid orbital. They have completed their bond, and in this case, first electron will be here, second and third. Now focusing on one carbon, that's here, it is a carbon. One hydrogen is attached over here and second hydrogen is attached over here. And in this case, One hydrogen is attached here and second is here. Now how pi bond is formed? Here is the formation of sigma bond. It is head-to-head overlap. When hybrid orbitals overlap head-to-head, they form sigma bond. And when atomic orbitals or hybrid orbital will overlap side by side, they form pi bond. And mostly those orbitals are unhybrid, not hybrid orbitals. In this case, they will overlap side by side, and it will make pi bond. It will make pi bond. In this case, the geometry is trigonal and the bond will be 120. Bond will be 120 degree. If you have any question regarding ethene, you can ask in the comment section. And now I am moving toward ethyne. Moving toward ethyne. Ethyne has formula hydrogen, carbon, triple bond carbon and hydrogen. It's ethyne. Same procedure will be followed by ethyne for hybridization. First, write its electronic configuration in ground state. Electronic configuration in ground state. 1s2, 2s2, 2px1, 2py1, 2pz0. And in excited state, we know that one electron from second s will jump toward 2pz, and its excited state will be 1s2, 2s1, 2px1, 2py1 and 2pz1. Now again look at the molecule. Find that how many atoms are attached with the central atom. Here we can take both these two carbon as a central atom. Just focus on this carbon atom. That in this carbon, one hydrogen and second carbon. Two atoms are attached with the central atom. So we can say that inner two orbitals, inner two atomic orbitals will intermix to form new hybrid orbitals. So we can say that these inner two orbitals, 1s and 1p, 1s and 1p will intermix to form sp hybridization, sp hybrid orbitals. These are sp hybrid orbitals. So we can say that ethyne will fall in sp hybridization. Ethyne will fall in sp hybridization. Now their block configuration is, I am going to erase ethene. One carbon and second carbon. One is two hybrid orbitals and unhybrid orbitals. One is two hybrid orbitals and unhybrid orbitals. Now I am going to name them. It is 1s2. It is also 1s2. It is sp hybrid orbital and it is also sp. It is also sp and sp hybrid orbitals. These are unhybrid orbitals, and one is 2py and second is 2pz. So it is 2py and it is 2pz. It is also 2py and 2pz. Now putting electrons, both sp will have just one electron, so here will be 1 and here will be 1. one electron and one electron. In this case, one electron, one electron, one and one. Now they are overlapping. First, carbon is making bond with another carbon atom, and in this case we know that one bond is sigma and two bonds are pi bond. So in this case, here will be formation of one sigma bond. It is sigma bond. With this carbon there is a hydrogen, so write hydrogen over here and overlap it with one hybrid orbital, and in this case one hybrid orbital will overlap with hydrogen atom. Now two unhybrid orbitals of each carbon are remaining. First is 2pz and second is 2py. So these will overlap with each other and will make pi bond. First pi bond, and here will be the formation of second pi bond. I hope that you have understood it. If you have questions, you can ask. I am going to revise it again. First, think just about one carbon atom that's here. In this case, we are looking at it is in the form of ground state. One electron will jump toward 2pz, and now electronic configuration at excited state, that in this case 2s1, 2px1, 2pz1 and 2py1. Now look at the molecule and find how many atoms are attached with the central atom. In case of ethine, if I am going to take this carbon as a central atom, then I can say that here are two atoms are attached with the central atom. First this carbon and second this hydrogen. So we can say the inner atomic orbitals will take part in hybridization, and in this case inner atomic orbitals are 2s1 and 2px1. These two orbitals will intermix, they will take part in hybridization and form sp hybridization, sp hybrid orbitals. Now their geometry will be like, first of all draw hybrid orbitals. Just two hybrid orbitals are here, so draw them at maximum distance, maximum angle. Maximum distance, maximum angle, one electron and one electron. Two atomic orbitals are still unhybrid, and we have to draw them in double row. First of all, drawing 2py. It is 2py. Now 2pz. Second carbon will have same shape as, and its orbitals are, it is the 2pz, and here will be 2py. These will have just one electron, and here will also be one electron. Now complete the hydrogens. One hydrogen is attached with hybrid orbitals, and in case of second carbon there is hydrogen attached with the hybrid orbitals, and here unhybrid orbitals are overlapping side by side, 2pz with 2pz, 2pz with 2pz, it's one pi bond, 2py with 2py. Here is the formation of second pi bond. In this case the geometry will be linear geometry, and bond angle will be 180. Bond angle will be 180. If you have questions regarding hybridization and their types, you can ask, and follow the description for other video lectures. I have mentioned previous lectures in description with their links. Thank you, and don't forget to subscribe my channel. Allah Hafiz.